Hello and good evening. My name is Vince. I'm the main organizer of machine learning in healthcare. And I welcome you to today's last edition before the summer break, which will be about a topic that is really, I believe, one of the most interesting topics in the field of AI, and that is how intelligent is AI actually? And you're really here to hear about this topic and to listen to the panel discussion and not to me talking. So there's only one thing that I would like to really encourage you, and that is ask questions. Leave your questions in the comments. Nico will pick up on them. And well, who is Nico? Nico is my co-host today from Meetup.ai. He will be the moderator of the panel. And with these words, the stage is yours, Nico.
Thank you very much, Vince. Hi, everyone. Very much like the community at Machine Learning in Healthcare, this is our last event before the break. We do like to keep the best for last. It's a very, very interesting topic of how intelligent is AI. If you have been to a Meetup AI event before, you know that the first thing that I ask is write in the chat where you're coming from. One of the main advantages of us actually doing those online events is that now we can be talking to all of you all over the globe. So if you're coming outside of Germany, or if you're coming outside of Berlin, or even if you're coming from Berlin, let us know in the chat. Also, send as many questions as you want in the comment section, and I'll be bringing it up in the chat, in the panel as we go. And very much like Vince says, I want to minimize my words because you don't come to see me speak. You come to see all of our amazing speakers. So I would like to invite everyone on stage. So I am joined today by Professor Dagmar Monet, Professor of Computer Science and Artificial Intelligence Software Engineering at the Berlin School of Economics and Law, Professor Michael Schmucke of Neurocomputation at the University of Hertfordshire, and Professor Maria Slavokovic, Professor of Machine Ethics and Logic Reasoning in Social Networks at the University of Bergen. I think it's very fitting that we have three professors actually to help us crack, let's say, a fairly complicated question inside of AI. Thank you very much for all of our speakers for joining us today. And if we're going to be talking about intelligence, I think we might as well start by defining it a bit. So I would like to ask each one of you, what's your favorite definition for intelligence? And I see Michael has already made a sign. So Michael, I'm going to give it to you first, then Dagmar, and then Maria.
Yeah, so my definition of intelligence is the ability to learn, the ability to memorize, and the ability to infer from what has been learned and act on the learned sort of content.
Very good. Dagmar?
So I must say that I don't have one favorite definition, but a lot of them. But one of the definitions that I find myself with, I like that definition, is from Thorndike, 1921, a psychologist. And it was in a symposium he defined, wrote about intelligence and defined that intelligence is the power of good answers. And I like that. It's very, very brief definition, but also of good answers because it depends on the culture, on who defines what is good or not. And the power of these responses is what maybe is what others perceive as being intelligent and not something innate to a human, to a person, to an animal, or to some object, but what people think about these answers given by this computer or person, etc. I like that definition. Very, very simple one, but we will have time to discuss about other definitions.
We're gonna definitely have a much broader discussion on that definition. Maria?
Time to discuss about other definitions.
Sorry, I'm
definitely have a much broader discussion on that definition. Maria?
I'm sorry, I'm having some issues with, I'm hearing everything twice. Sorry, I'm
definitely have much broader. All right, apparently Maria is facing some technical issues on her side.
I'm having some issues with, I'm hearing everything twice. Sorry,
All right, apparently Maria. So Maria, I would just recommend that you leave the stream and then follow back in the same link, and then Vince is going to let you in. And then no worries about this. As I always say, my events, the earlier the technical issue, the better. So I think that the next question that would kind of come up, it's basically if it even makes sense to ask if something such as artificial intelligence is intelligent. Like in our definition, is our definition of intelligence too human-centric, maybe to be able to ask a machine of that? So Michael, your definition, let's say, is very is short and direct, and in that sense would maybe fit the machine well, but how do you feel about it?
Yeah, I think that the reason why my definition is short and direct is because I'm biased towards trying to making machines sort of intelligent, right? So that influences one influences the other. And yeah, I think, well, in principle, my standpoint is machines can be intelligent. I don't think there's anything miraculous about the human brain that makes it impossible for machines to get the same amount of intelligence. However, I mean, there is something miraculous about the human brain, which is it is so super capable of learning, and also it has huge memory and all that, and it does it over a whole lifespan. So I think that's what makes it stand out against all the other machines that we are training to be intelligent, all the other algorithms.
That's a very, very good point. I like the thing about nothing miraculous about the human brain. That's a very interesting point. Maria, let's try again. Let's see if your issue has been fixed. So what's your favorite definition of intelligence? And the question that I added to the panel was, does it even make sense to ask if a machine is intelligent?
Right, so yes, all sorted. The bug was very stupid, actually. Sorry about that, my fault. So my favorite definition is that AI is the discipline that is concerned with automating cognitive tasks. So building machines that behave, that do tasks that require intelligence. So for me, this one I think is Bell, 1978. Bellman, not Bell, sorry. But I'm not entirely sure. And the next question is, does it actually even make sense to ask whether machines can be intelligent? I would say, why not? I mean, we ask whether animals are intelligent, we ask whether plants are intelligent. It's a very flexible definition. Is it anthropomorphization? That's the actual question. And to that, I don't know. I honestly don't know. Right now, at this point, yes. But it's a slippery slope.
That's a very good point. Dagmar, what about you?
Yes, I think it is a very valid question. We are interacting with these artifacts, so asking whether they can do the same things or similar things as we do, or maybe reason as we do, could mean that we try to compare them to us. And we are intelligent beings, so why not then asking whether they can be intelligent too? This is a different question. How do we define intelligence in machines, which is maybe not the same as defining intelligence in humans, but I think it is a valid question, and I like it. I think it has also guided the research in AI since more than 70 years, actually. It's such a question.
Actually, there's a point that a lot of people like to bring, let's say in little cocktail parties, that is the name itself is misguided. And a lot of people working inside of artificial intelligence today, they feel that this is much more of a marketing term or something used to kind of bring people along or to kind of get funding than actually representing the technology behind. So I wanted to ask the speakers, do you like artificial intelligence as a name for a discipline? If not, like, do you know anything better? Do you know why we kind of got stuck with this? Whoever wants to take the question first might take it. I will see the first one to unmute themselves as the first one to want to take. So it's Maria's question.
I had to go for it. I mean, the name comes with the field. We have a beautiful origin story as a field, right? Several people got together and wanted to solve all the problems of AI in one summer. However, little did they know that they were wrong and they created a discipline. So, I mean, is there a better name? I don't know. All names will be bad. What I have a issue with is that sometimes people confuse artificial intelligence and artificial life. I think that's where the confusion sometimes overlaps. And then we have all kinds of nice exotic discussions about, can you create this ultimate artificial being that has the same cognitive abilities as a human, and how are we treating them, and so on. But that's a question for artificial life. If we create artificial life, all of those questions will be very pertinent. I don't think that, I mean, yeah, it's a buzzword right now, but it has existed before the buzz, and I think it will exist after the buzz.
Very good point. Somebody wants to take it? Michael?
Yeah, I'm with Maria on this. So it's a buzzword at the moment, and I think it's overused sometimes, even to include like things like statistics and all that, right? So we have an AI model, and all they did is like linear regression. So this happens, and I think that's a sign of our times, and it's a huge buzzword, and this will change again in a couple of years. But in general, I think artificial intelligence is a great name for a discipline and for a research topic, right? So we want to build something that's intelligent, and that sort of implies that we're intelligent too. So I guess that's why people like it as well. I don't know, but I think it's a good name.
Dagmar, I know it's definitions are one of your favorite topics. So is that a good name?
Well, I think it is a name. So I didn't question my parents why they call me Dagmar or not. So and artificial intelligence, artificial for me means maybe in general it is made by humans. It is not a human thing, but made by humans. And I was grow up with this artificial intelligence as name, and for me it is not a problem calling it artificial intelligence. There are people that think the name of the field should change. And I think it correlates with how much people know about what is behind. So what are the algorithms? What are the methods? What are the subfields of AI? And normally when people don't know, then they think artificial intelligence can be everything up to Terminator and something like that. And this is why there is a lot of confusion. But I like the name. I didn't question it, but like to study, like to investigate what does it mean, but not whether it is a good name or not. So I agree with Maria and with Michael.
There's a quote, if I remember correctly, there's something about like all baby names are good names unless they're bad ones, then they're bad. I think that's something that comes to mind now. Or artificial intelligence, like everything would work unless it's bad. If it's bad, then it doesn't work. There's a question from the audience that goes into a direction that I would also like to go with us, and that's from Heiko Goes, and he asked, there has I think a distinction between us and machines is that we have emotions and gut feelings too. And actually, I'm going to take Heiko's affirmation and I'm going to ask, is gut feeling something truly unique to humans? Or is this just being able to do a quick analysis given insufficient information? Could machines get gut feelings? And I know this is a bit further away from what we normally treat at Meetup AI, but could we teach machines emotion or empathy? Machine empathy has been something discussed before. Who wants to take this tricky topic first? See Michael doing a little hand movement there, so I'm going to give it to him.
I was hovering over the unmute button and just waiting maybe someone else goes first, but okay, I'll take it. So I think that's a very important question. And personally, I think that gut feeling, emotions in general, it's also a form of memory. It has evolved sort of below the level of our conscious memory, right? It's something like an ingrained memory that we can't really grasp, but we have it. And since it's memory, I don't see why it couldn't be built into machines too, right? So there's no principal reason why it couldn't be. I think why our current sort of AI machines don't have gut feelings, I mean, there are some approaches that try to do that, but I think why it hasn't taken over yet is because perhaps we don't quite understand the role of these gut feelings, where they come from, these emotions in general, where they come from, what they're good for, what their real emotional evolutionary purpose is. If we would understand that, maybe we would also be able to build better machines that might have a gut feeling, right?
That's a very interesting point. Does anybody wants to get into the emotion part of the discussion, which is a tougher one, I would say? Dagmar?
The case is that if we want to implement emotions in machines, we need to code that. So with a programming language. Yeah? So if this happens, then this is what should be as a consequence. Or if this happens, then it should then manifest, or maybe write something on the screen, or doing something that seems to be an emotion to the people that are interacting with the machine at that moment. But this is not my speciality, but I would say this would be something like the AI effect. So once we know how it is implemented, well, it is a sort of if then else and this and that, then we think, oh, but this is not emotions, so we don't feel like that. Or maybe we should call that emotions in machines will be very different than emotions in humans. And this is what I think it will be always the case. So they won't be able to feel something, but only to follow code instructions and then seem like they are feeling, but actually then repeating what is code inside.
That's a very interesting point, Maria. Though for you, I know that you have a very interesting point about how much intelligence is just really understanding what the machine is doing, that something is only intelligent if we cannot really understand it, maybe. So I want to give it to you also to go into that direction.
To me, saying that the difference between machines and humans is that humans have emotions and machines don't have emotions is the same like the difference between a plane and a bird is that the wings of the plane don't move, whereas the wings of the bird move, right? And these are two different things, right? They both fly, but they do it in a completely different way, but both of the actions are flying. And so in the same way, machines do some cognitive tasks, humans do cognitive tasks, but they do it in completely different ways. There is this very beautiful, for the general audience, there is this very beautiful, but although very long, lecture that Richard Feynman has given on what computers think, what do computers actually do when they compute, is very old. But it's by him, who is very good at lecturing stuff, and it's somewhere on the YouTubes. And I suggest anyone who is wondering what AI is doing to check it up. It hasn't changed since Feynman gave that lecture. Computers still do the same thing. But
It's a very, very good, interesting point. But I'm going to take now the point of like I am an economist. That is the cross. Oh, Michael, take it.
Sorry, just something came to my mind. A very important consequence, if we were able to endow machines with emotion, I mean, there are, of course, then ethical implications, right? So if a machine has emotions, what does this mean, how we can interact with it? Can we simply switch it off? Is this still okay, right? These are questions to us. That's something that Anil Seth is considering a lot. So he's leading the Sackler Center for Consciousness Research in Brighton, Sussex. And I just saw a panel with him the other day and found this a very interesting concept. And especially we wouldn't even know if we had already built such a machine, if those machines, a machine that would be conscious with emotions and all that. So we might have already built one, but we wouldn't know, and because they might express their feelings on a totally different level. So I think that's a very interesting aspect.
I could imagine a researcher having to teach a machine to feel emotions in a similar way that a mother teaches a child to be sad when they hurt their little playing buddy, like trying to teach empathy or those basic emotions to a child that is still trying to figure out what are those feelings are. And that would definitely bring some ethical implications depending on how everything goes. Ankush makes a very interesting point. He says, like, isn't our emotions a if then else scenario? Like if somebody's crying, then feel empathy, like show care. I know that in Japan, for example, they already have like elderly assistants, which are supposed to understand like, they're sad. Let's change the voice low 10% and speak a bit more slowly.
Cognitive science, okay? This is not AI. I feel epistemic trespassing happening here majorly. So let's not go down this rabbit hole because you need a bunch of cognitive scientists to discuss this. I personally
so let's bring a bunch of cognitive scientists. But something that about this discussion does actually bring to mind is the idea that is only a machine would only be intelligent if it can mimic what humans can already do. So I think an example that comes often is that when people think about Deep Blue winning at chess, we thought like, oh my God, this is artificial intelligence. But when we see artificial intelligence let's say, optimizing multiple processes across a hospital, we don't necessarily think that that is artificial intelligence. So why do you think there's such a big divide between how people see different? Sometimes it's basically the same model or the same idea that kind of beats both challenges. But why is one considered intelligent and the other one is just considered a program, software? So what makes artificial intelligence that? Whoever wants to take it. All the questions are tough today, guys. There's no easy question coming anytime soon.
Start asking AI questions.
Sorry,
Michael?
Yeah,
And
I
then
was
Maria?
about to say, like, I think that might be due to a bit of confusion that's hanging around about, like, what is the term artificial intelligence and what's the name of the field artificial intelligence, right? So when Deep Blue like beat the world champion in chess, then artificial intelligence was actually, the field of artificial intelligence was actually studying chess, right? Today, chess is solved in the field of AI, and AI is dealing with other questions. Whereas, I mean, I don't know, I could still understand if somebody called this computer program intelligent that beat Kasparov. And
But
yeah,
you wouldn't, Michael. Let me just frame you on this one. Would you think that the programmer that beat Kasparov was intelligent?
That's a good question. I would have to think about it a little.
So you're gonna hold that question for a second, because I want to hear Maria's thoughts on that. Not that question, but on the general point.
Well, I mean, there is this phenomena that whenever a company solves this hard challenge, their stock rises, and it's very important that to have this perception that progress in intelligence has been made, because actual progress is in fact not so glamorous, and I don't think anybody makes directly money out of it. But we anthropomorphize everything. That's how we relate to the world. This is a very human thing to do, and for us to understand that something is intelligent, it has to be, or something is hard, it has to be hard for us individually as a person, right? So whatever a person themselves finds hard, they're going to consider that hard cognitively, they're going to consider that to be intelligence. And this is going to not be a question of humans versus machines, it's going to be a question of one person versus a machine, right? So when people were doing math in their own head or on their fingers with these little tablets, then the calculator was super intelligent. It was magical. And right now, I mean, people have this one super specialty, right? We are very good at adapting. That is our superpower. We adapt to things. Do we need machines to be intelligent in that way? Is that intelligent? I don't know. I mean, is it fun to have these things that play games? Yes, and I think we have a long tradition with chess since the Mechanical Turk, the long dream, the long con in a way. The Mechanical Turk was this device that was built to con people into thinking that we have an automaton that can play chess. There was a person inside all along, right? And today we have the same situation where, like, oh yeah, but we built this machine to play chess, but that machine itself does not move the pieces on the board, right? It plays a screen in a way. It plays with the data stream, if you like. So then the next thing is like, okay, but can it actually just also move the pieces on the board? So I believe that's the next level. It's still chess, but you're with the manipulation itself. So it's moving. It doesn't matter. What matters is what you want. What does it mean to you for AI to succeed? So Stuart Russell, in his book, which is called Human Computable, I just finished it. He says, like, this very eye-opening thing inside. He said, what if it works? So I think more than what does it mean for AI to be intelligent, I think the question to ask is, what does it mean for it to work? And then it's, what does it mean to you individually as a person in AI, as a person in cognitive science, as a person in business, as a person in academia, as a citizen, then as a netizen, whatever you want. That would be
very, very good point, Dagmar. You can take the same question, or I can give you a slightly different question that I know is an important topic for you, which is, we're talking a lot about AI and intelligence, but there's also a question of AI literacy. So the importance of actually understanding what's going on to be able to properly ask, let's say, the right questions. So your choice, do you want the literacy question or you want the humans only value that which is hard question, or both?
Well, they are related. They are related. So AI literacy is knowing about what AI is, what the subfields are. And for example, today, a lot of people think AI is on machine learning. Machine learning is one of the different subfields that AI has. And it is now the case because machine learning is having a boom, a renaissance since 2010, more or less. So, but it is a very old subfield of AI, actually from the very beginning, and a part of the field. And AI literacy, so knowing what those algorithms do, what the subfields are, what are the really hard problems that need to be solved, where we have not found a solution now, but also the mixing what humans and machines are capable of. I think all that belongs to the same thing. And this is why, for us, still, problems that are very difficult to solve, we associate a solution to those problems with intelligence. And it is a very natural association. So when problems are defined, maybe they can be very good and detailed defined. But when we don't find a solution for that, then we think the first one that finds a solution is a very intelligent person, because it is able to find, maybe to connect dots or to find some mechanisms that nobody came to them. And maybe we say, because of that, this person is intelligence, or the machine is intelligence. But what we have now is an evolution since the very beginning of the history of AI, since the very early years, which didn't start with the workshop, the Dartmouth workshop, but also before, were founding works and articles and science behind that were the fundamentals of AI. Since the very beginning, we have the same thing. And Minsky, for example, 1985 in the Society of Mind, that was one of the definitions. So being able to solve hard problems. The question was what a hard problem is. And then it was someday trying to win chess. Then later, some years later, was winning at Go. And DeepMind, for example, have almost solved that problem with Go. So at least that a machine can win when it competes against humans. So it will vary. It will vary according to what is the problem we want to solve. And actually what is behind is they can make a lot of calculations in milliseconds, much more than they could do years before, or maybe a week before. And then it can happen to us that they are intelligent, but that's not genuine intelligence. So part of the AI literacy to close the cycle is knowing what these algorithms are, what they do, etc. And I think it can start at all levels. So not only computer scientists, not only cognitive scientists, not only people dealing with AI in some way, but also the general public. This will be important because we are interacting with such systems that have AI behind. So knowing how they make decisions, maybe, and not maybe, it will have a very important effect in how we interact with these machines. If we get a job or not, if our children get to the university, if maybe there is a wrong decision and because of that it have some implications in our lives. So interacting with these systems is not the only thing. We need to know what is happening behind, to question what these algorithms do. And one of the best ways is to know a little bit more about AI.
I have a friend who talks about nobody needs to know how to build a car, but most people should know how to pop open the trunk and understand what is an engine and what is like a gearbox and like the very basic concept. So maybe it's a similar concept. Maria, I have a point for you that I know it's dear to you as well. And it is, does it make sense to talk about intelligence when we don't have autonomy yet? Or is autonomy maybe a precursor to intelligence?
So for me, the more interesting question is, what does it mean for something to be autonomous rather than what it means to be intelligent? Because is this thing intelligent is like asking, is it fast, right? You have to evaluate within a context. A context, you have to evaluate with a particular goal. What I find very interesting is that the tricky thing is autonomy, because at least in my opinion, I don't know. So one of the other differences between machines and humans is that machines follow rules, whereas people can break rules. I can just say, well, okay, I know that this is illegal. I know that it is immoral. I know that you really don't want me to do it, but I'm going to do it anyway. And sometimes that's actually a good idea, and it is the right thing to do, and it's the smart thing to do, or exactly what humanity needed at the time. And to evaluate whether or not a machine is autonomous is actually very tricky, because what does it mean? Does it mean that it can just say, no, I'd rather not follow this rule right now? What does it mean to build machines that are able to refuse to follow rules? I have absolutely no idea, right? Because there is this standard of engineering standards of how much control does a machine need in order to be able to operate, and they divide it roughly between supervised, controlled, automatic. This would be your elevators, they're automatic. And then you have autonomous, and then here the floodgates open, because everything here, from the rovers on Mars to the vacuum cleaners on the floor, falls somewhere in this spectrum of intelligence. So at some point we will have this autonomous behavior that is basically a bunch of, we cannot actually follow how does this choice of the machine to do this at this point relate back to its initial program. And the really interesting question is at which point does the tether break, and you have something that you can call an autonomous machine?
It's a very, very interesting question. And that actually plays along with what Austin Rayner wrote in the chat, which is, how does artificial intelligence handle ambivalence? I want to do X, but I also want to do Y. So in a complex social scenario where multiple things have to be achieved at the same time, and a machine has to kind of understand the trade-off being played between its own, let's say, responsibilities. And that would be autonomy, right? To be able to differentiate, I would do A rather than B, or would be a one version maybe of this.
Yeah, I think that's still multi-criteria decision-making to an extent. It's more like, I don't want to do this, but why? Because I don't want to. There is a quote from a book that I've never read, but I'd rather not, I think is the quote. Some scribe says that.
That's a pretty good. Please keep going. I see that the discussion on the channel is going very, very quickly and very, very nice. There has already been, I wanted to actually hit the clock, like how long would it be before somebody asked the first AGI question? And apparently it was halfway through the panel. So congratulations to this crowd, because that means that we have enough discussion about the short term to occupy us. But I do have a question, which is not AGI, but it is something, let's say, along the lines, which is there something that we should not try to teach machines? Is there something that is just silly to even try to codify or program? And Michael, don't forget that you still owe me an answer. So you're going to answer me first if the machine that beat Kasparov was intelligent. Meanwhile, the other speakers are going to think about the question, is there anything that we shouldn't try to teach machines because it's silly, or because we cannot do it or won't be able to do it? Michael?
Mm-hmm. So, actually the answer is quite straightforward if we apply the definition of artificial intelligence, at least like for me, because I had this definition that allows me to be applied to this program. And unfortunately, I don't know enough about the program itself, that Deep Blue, like how it exactly operated. But if AlphaGo and AlphaGo 0 are any measure, then this system, it can learn. So it plays against itself, so it learns. It can memorize what it has learned, because it forms all these policy functions and all these internal representations. And of course, it can apply what it has learned to new situations, right? So it can decide what the next move will be, even if the current state of the field has never been covered in any of the games. So by applying this definition, I would have to admit, I would have to call the program intelligent. Although somehow intuitively I probably wouldn't, because I know it's a program, right? It's bits and bytes. But yes, by the definition, it's intelligent.
All right. So I was going to say, like, given Michael just made a decision based on incomplete information, which we call like gut feeling. Let's just see how long it takes for a micro machine to be able to provide that same kind of answer given uncertainty. So we're back to our question. Is there anything that we shouldn't try to teach machines? Or at least we can even go, we shouldn't try to teach machines in the next 5 to 10 years, if it makes it a bit easier. Whoever wants to take this very, very complicated question. If nobody volunteers, I'm going to give it to Dagmar. So Dagmar, you volunteered.
So I think a very common sensical answer could be we shouldn't teach machines to do what we don't want someone doing it. And this applies to a lot of different things. I don't want someone discriminating me. I don't want someone violating my rights. I don't want someone making decisions instead of me, and that somehow deteriorate my way of living, my future, the one of my family, of my friends, of society, of the nature of the society and world we live in. So all those things, and there is the spectrum is very, very broad. We shouldn't teach machine to do anything that goes against such rules that maintain societies working, like, for example, democracy or human rights or whatever we want to take. We shouldn't code programs that go against those rules and what we have found over millions of years that makes societies or the world or countries or regions function in some way. So function, evolving to better stages, to better ways of interacting and living in this planet. So anything that belongs to that set, and there is a lot, we shouldn't teach machines to do that. It means we shouldn't code explicitly machines or algorithms that do such things.
So the red lines in your case, they are much more ethical and social than they are technical. That's a very interesting answer. Who wants to follow up with that? That's a tough one to follow, by the way. So I see Maria looking at me with very intense eyes. I feel that she has an opinion about this.
These are my
So,
eyes, Nicholas. It's nothing I can do about it. No, I'm wondering whether what you want to ask is there something that machines should not be used for, rather than is there something we don't want to teach machines? Because everything that has power can be abused, right? No matter, you may have the best of intentions and you can teach this machine to do this, and then the street will find its own uses for it, right? So then the question is there some uses that we should be actively preventing? My rule of thumb is that you shouldn't let machines do human jobs. That being, if the job requires a lot of finesse and use of what you call gut feeling here, then you probably should not put a machine in that job. If the job requires empathy, it requires use of emotions, it requires evaluating the person in front of you, not following a decision tree to make a decision or not following some regulation, then for this type of a job, you probably want to have a person. If you cannot describe the job sufficiently easily to hire somebody very cheaply to do it, then you probably don't want to put the machine on it. And I think the interesting thing for me here is that people very get excited about very powerful, very sleek machines that can do these very complicated tasks that we ourselves struggle to do and so on. And in the meantime, we as humans, we suffer. Every one of us has these tasks that we have to do in our daily life that we would rather not do, right? So I would say free the humans to do what they want to do, which involves a lot of creativity, emotion, being aware of the situation, evaluating the situation, and so on. And use the machines to take over the stuff that we generally don't like to do. Cleaning the aspirators in the kitchen, cleaning bathrooms, floors, picking strawberries. I mean, this is stuff that we all struggle with, and this is where machines should be used. This is my religious belief at this point that you should leave the human tasks to humans and build machines to do stuff that we don't want to do. So don't think about where should we not plug in machines so much. If it is a question, then it should be considered seriously. But the question is, what do you not want to do as a person? And that's the slot where the machines will go, I think.
That's a very, very good point. Michael, you're going to cut. Dagmar wants to comment on it. But no worries. I just want to say, Michael, when you answered that question, I want you to take a more of a technical view on this. Is there anything about human intelligence that we should not even try to teach machines, in the sense of like, we won't be able to succeed? Like, it's something that will be too complicated to try to mimic. And I'm asking this specifically of you, Michael, because I know that you're working on some very interesting ways of making machines more human. So you can also talk a bit about that. But Dagmar, you wanted to comment?
Yes, I wanted to add something very briefly, and it is the following. So who are the ones that are implementing such machines now? So maybe at research centers, at universities, in academia, etc., but more and more in industry. So what we have now is not what maybe the lay person would like to have in machines, but what is a product and interests of companies driven. So what they are doing is what, of course, applies and suited what they want in order to build products they are interested in, mainly, and not always in interest the users that use such programs. So these machines, what they can do or not, what we have now is what companies actually decide what is good for the companies, and some of them, of course, what is good for society. We have a lot of different solutions to very, very pressing problems now. There will be more of that. But the layman, the laywoman won't have the possibility to do that. So it is a matter of power. Who has the data? Who has the algorithms? Who has the computing capabilities, the computer centers, etc. Those are the ones that are now deciding, determining, defining what are these algorithms, machines, etc. that we are using. So it is something we also have to add to the equation, is the comment.
That's a very, very good point. I'm just going to throw my hat in the ring on that one, because in economics, we famously say that it's the demand that creates a supply, it's not the supply that creates a demand. So if humans were asking more and more for products that would do those things, then the large centers of power would say like, oh, this is a way to make money, and then somebody will try to make it. So what we're demanding is very often what we're getting, let's say as a broad consumer group rather than individuals. But I'm going to be sending the question from De Creer to Maria soon. Let's just get Michael first to ask. And Michael, can you mention what you're trying to do there with olfaction in machines, for example? Because I think that's very interesting.
Yeah, so I think I first try to answer your question, what I think we shouldn't do. Or actually, I'm not going to answer it, because I think if there's one thing we've learned in the last 10 years, then it's as long as there's enough data to learn from using the various algorithms that we have and we're developing all the time, and new ones are coming up, and as long as there's enough data, superhuman performance can be achieved or has been achieved in all domains that we have tried, right? The challenges at the moment are more like in the motor domain, right? Actuators and so on, like when moving the chess pieces not to break the board, these kind of things. But so I think it's hard to say what we shouldn't even attempt to teach machines, because as soon as there's enough data and some problem, I think it can be learned. Because humans, in the end, we just accumulate data. We learn from our sensory experiences and interactions. And I don't see a point where a machine should not be able to do that, given the same amount of data and the same sort of algorithms, the same capability to extract information from that data. And yeah, olfaction. So yes, we're working on olfaction. It's a very interesting topic. It doesn't have to do so much with intelligence, because we're really on the sensory data. And to sort of tie this in the documentation, in the discussion, sorry. think on the sensory level, we've gotten quite far concerning intelligence, artificial intelligence. So sensory processing in almost all domains has surpassed a human ability, except in olfaction, right? Where we're still behind.
Oh, nice.
But we're working on it. So yeah, that's
Michael, do you think if we created an artificial intelligence which was a master chef, would it be considered a master chef? It could not taste cake. Like,
I think there's much more to a master chef than just making a cake, right? So it's the guy in the famous restaurant that's acclaimed by all the critics, and then you go there and you have this feeling as soon as you enter, this is something special, and you see the menu, and even the tiniest bit has 3 figures on it. So that's what a master chef is, sort of what defines a master chef, not whether he can taste cake or make a nice bouillon or something, right?
Maria, we have a point from the creator. It's actually not directly regarding intelligence, but I just think it was worthwhile given your very strong, passionate defense, which is
thank you for that question. I saw it. I was like, ooh,
all right, then take it. Awesome.
All right, but before I do that, I have to reply to Michael. I don't agree that having enough data means that you will learn something eventually, because this is how AI entered its second winter. But at one point, there is this thing called computational complexity, which kills you, because even regardless of some problems are simply hard. Okay, some things are simply hard, and the one thing about humans that we have not, that humans can do and we have not recreated in machine learning, is learning from small number of examples. I show you 2 chairs, and forever after you will be able to recognize the chair, even when it is covered with a lot of covers, even when somebody is sitting on it, even when it's in nature, you will be able to do it. And there is a reason why machines can't do that. In fact, there are many, many, many reasons why it's not always a question of data always. Now you can reply to me. I just need to very quickly reply to the creator here. This question is the same as feminism, okay? So it's about the freedom to not do something. So feminism did not mean that, from now on women are not allowed to be homemakers or they should not be homemakers. No, it's just the choice. If you don't want to, you don't have to. I don't believe in dumb jobs, but there are jobs that are strenuous to your health. They're strenuous to your body. And maybe this is something that you enjoy. And if you do, then you should be properly compensated for it, because you will always be far better at it than any machine. Well, I'm going to go ahead and put it out. I'm going to risk it and say human will always be better at doing a job that they really, really want to do than a machine. It's about giving the choice to all the other humans that want to be, something else, to not have to do this job just to make a living, right? That's what it is about.
Maria, you would be a great economist, Maria. You would be a very good labor
economist. I think
economist.
I'm with you guys too much. It starts to show.
Can you bring also Robert Kirby points about sorts of psychologists? Because I find it interesting also to discuss. And he says psychologists have identified many different types of intelligence, among them kinetic, mathematical, emotional. And he calls programs that only address 1 or 2 idiot savants. Is this basically what artificial intelligence is? We're just trying to create a multitude of idiot savants to fix our daily problems? Or is there hope to be able to get broader than that in the short term? Short term, I always mean short term, 5 to 10 years. So that we have a bit of time. Maria?
It's a yes on me. I don't think that, and without having a very good reason to go broader, we shouldn't go broader.
That's a very good point. Dagmar?
So in other words, we don't have intelligent machines, actually.
Yeah.
We don't have so we say they are intelligent, but they are not. So they are like those savants, only in very narrow scenarios doing something, but this is not intelligent.
Imagine people coming in for their first AI event, and this is it. Oh my God, I'm finally going to understand what artificial intelligence is about. And 3 people, top of their fields, being like, yeah, we don't truly know how things are going. Can go anywhere, can go nowhere.
Well, adjectives are very, very beautiful. So maybe it is we don't have truly intelligent machines. And maybe this softens a little bit, no? The thing.
It's a really cool point. I got a question from the audience before the event started, like a friend of mine who's joining, and I even put it in later on. I wanted to put it in later on, but I think we're almost running out of time. And then the question is, why are we trying to learn only from human intelligence? Human intelligence, let's say, if we're trying to learn from biological intelligence, why only learn from humans? There are multiple other animals which are intelligent in different ways than humans. And are we trying to learn something from them when it comes to creating artificial systems? Michael is nodding, so I'm going to give him the answer first.
So I mean, in neuroscience, the whole field is studying neural circuits in various animals, and even honeybees display some behaviors that we have to consider intelligent, really. And by understanding those circuits, by learning about the circuits, we learn something about the underlying computation, and we understand that computation, and then we can then try to transfer this computation into technology. I think, yes, so we do learn from other species. And actually, the whole thing about vision convolutional networks, this was vastly inspired by the visual system of animals, of primates, also including humans, but also other animals. So we see these principles all over in the animal kingdom, and so we're copying it, and it gives inspiration to machine learning algorithms. This has always been the case. Much of it came out of neuroscience, which is not limited to humans. Thank God. Yeah.
Very good, Maria. I saw you nodding as well. So the nodders are getting the questions now.
We are. In fact, there is this whole field of, in robotics especially, you see this, right? So you have swarm robots, which are trying to recreate the behavior of a small swarm, which is an intelligent behavior on its own right. This is a lot of little things comprising one agent behavior in a way. And of course, you have all kinds of soft robots that are trying to change their shape in order to fit somewhere. This is not something that humans are able to do. So we do have quite a lot of that. It's just right now we think of intelligence as something that is, we always have this idea of, recognize who I am, recognize my voice, predict what will happen to me in the future. And this is not something that animals do. But we have a lot of, in robotics specifically, but also in decision making, what Michael said. They have studied bees, ants.
Very good.
Slime, I believe, somewhere in a university that is being used. Slime. Some kind of I don't know what the species is. It's some kind of a. I don't know. Sorry. It's something that has the ability to make find shortest connections between points.
Yes, it's an amoeba, right? Wasn't it an amoeba or something like that?
Solving the traveling salesman problem. Was it that?
One.
Yeah. Mm-hmm.
Yes.
Exactly. Dagmar, before I send it over to you, in case you want to take that question as well, I also have to bring the last question for the panel. So the last question for the panel is, normally I like to finish our event with something a bit uplifting. This time, I want to ask each of you to just say a few words, like from the audience watching, if you want to say a few words about, is AI intelligent? What do you think that they should take home? So Dagmar, you can choose to answer the question about if we're learning for animals, or you can be the first one to answer, what should people take home about, is AI intelligent? Your choice.
Very briefly, the first one, the ant colony system. So more than 20 years ago, they were very famous, competing with neural networks based systems, and they are based on the behavior of ants. And where intelligence emerges from the interaction of the ants, from the interaction of the single individuals that are not intelligent as individuals. So this is a very long tradition in meta-heuristics with ant colony systems and swarm optimization, etc. So there is a lot also happening since decades in AI that take a look at how animals behave. This is what I wanted to add.
Very good point.
Yeah, but once again, the questions of whether AI is intelligent, that's the big question. I don't think it is. There is a lot that must happen in the field in order to have truly genuine intelligent machines. I don't see that in the horizon. So not short term nor medium term, maybe long term, I don't know, 60 years, 50 years, 100 years. So to truly be intelligent, there must happen a lot of things that we don't have that now in our methods, in our machines, in all what we know it is cooking in research centers and so on. So, but they are very, very interesting, coming together, meeting up of subfields of AI. There is a lot of work happening, for example, in combining the traditional, in some domains, still very, very useful and powerful rules-based systems or GovAI with other kind of methods, for example, from neurocomputations, etc. And I think this would be the kick that will change the arrow pointing to the future of AI. So I am very, very certain that we have a bright future. But where we are pointing now, it is not the way. We should change. We should bring more multidisciplinarity into this research and developments, etc. And then maybe we will be talking in 10 years and 20 years about the first, more or less, intelligent systems. But now, at this very moment, I would say we don't have them.
All right, Michael, then you now, and then Maria is going to close the panel for us. Whatever you want the audience to bring home. So whatever the final words that you want them to think when they think, is AI intelligent?
So I think it's really a question of definition. If the definition is that an intelligent system learns and memorizes and can act on what has been learned, then yes, I mean, there are many things that can be called intelligent like that. Now, if you're looking for something more complex, like what Dagmar describes, and of course, no, we're not there yet. And we probably also would be out of a job if we would. So there's a bit of a conflict of interest there. So, but my answer to the question is yes. Machines, today's programs, some of them are in fact intelligent after this definition.
Meetup AI in 20 years' time will have its own machine as a panelist, so they will be able to answer. Are we
sooner than that. Wait 2 years.
Maria, to finish the panel, then your final words for the audience.
Sure, why not? That would be my answer. Look, a computer does one thing, only one thing. All of the computers that we have, they do one thing. They look at two things, right? These two things, and they tell, are these two things the same color or not? That's the only actual capability a machine has right now. And by only using this capability, we are able to have amazing things. Some of them doing intelligent stuff, like recognizing whether or not there is cancer on this X-ray. Mapping this image of a face to me, as my face, right? Automatically translating text from one language to another. Just by doing this, comparing whether these two things are the same color or not. We don't need to go look for magic and fascinating things in rebuilding brains. I mean, of course, it's an interesting question. But in its essence, is it intelligent to just using this comparison of two colors in order to recreate all of these things that people can also do? Why not? Right?
That's a very, very, very good final words. With that, I would like to thank all of our panelists for coming in today, sharing their time and insights. It was a very, very valuable discussion. I don't think that we managed to close this topic yet. Maybe we need to do a full event just on what we're learning from animals in artificial intelligence, because I feel that there's a lot there that can be discussed. But to everybody that has been watching us until the end, thank you very much for your attention. Meetup AI is going on a break. Machine learning healthcare is going on a break. So take a look at the other videos on their YouTube channel. There's a lot of very good quality stuff. And because Vince is too proud to say it, like and subscribe. They do very good content. And it was my pleasure. Thank you, everybody. Dagmar, Michael, Maria, and all of the community. Thank you very much. Vince,
thank you very much from my side as well. Thank you very much for you at home watching. Until next time. Bye-bye.
Bye-bye.